Okay. There were some examples we missed in the first video, so we're just going to touch on them right now. It's the same stuff, it's just a couple examples that go along with it. So here we go. Write the following sets listing the elements within braces. 2-digit perfect squares. So this just gives us some practice in writing out sets. So we want to make sure that we can call anything we want. I'm going to call it set P. So P would be 16, 25, 36, 49, 64, and 81. Those would be the list or the set of 2-digit perfect squares. Now, in hindsight, because the next one talks about prime numbers, I'm kicking myself because I'm thinking I would have really liked to call the next set P for prime numbers. Oops! So, maybe I will call it something else.
I'll answer.
Just because it would make sense to call this something other than P. If it's perfect squares, why don't we call it set S? That makes a little bit more sense. Then we will go on in part B and we'll call the prime numbers set P. Okay? So, here we go with set P. Set P is the first 7 prime numbers. So what's the first prime number?
Alright, bye.
What's the first prime number?
1, 2.
It's 2. 1's not a prime number. 2, 3, 5, 7, 11, 13, 17, I think. 1, 2, 3, 4, 5, 6, 7. Yeah. There's the first 7 prime numbers. The only even number that's prime is 2. After that, they're all odd. But not all odds are prime numbers. For example, the number 9 is divisible by 3. So the number 9 would not be a prime number. Okay? Okay? So, that's how we write sets. With a capital letter, brace brackets, and we write out what is inside. So now, let's go on to the next example. And I'm going to modify this a little bit, because it's been a little while. Mr. Murnick, Mr. Hutton, Miss Anderson subs here, but she doesn't teach here anymore. So why don't I put Mrs. Knight here?
Why didn't you put Johnson?
Okay. So interpret the following sets. So we want to say what these sets mean. So in set A, Mrs. Knight, Mr. Murnick, Mr. Hutton, what could this be a set of?
Set of teachers. Set of teachers.
What type?
Set of teachers.
A set of teachers? What kind of teachers?
Math.
Teachers.
Math. Okay, good.
The math nerds.
Okay, so part A, math teachers. Math teachers at Frontier Collegiate. That's what it could be a set of. Okay? Now part B, we have another set, and here's the set. Walking, rollerblading, biking, mass transit, car. What could that be a set of?
Moving objects.
Transportation. Transportation.
Types of transportation. Or yeah, types of transportation. I'm good with that. Okay?
Mechanical transportation. Just kidding. Oh, never mind. Walking.
Rollerblading, biking.
Okay? Types of transportation. We're not going to talk about flying cars. That was about a half an hour. I wish I had back. I had that conversation with my grade 10s a couple weeks ago. So we're not going to talk about flying cars, but
Remember in Back to the Future we thought that was going to happen?
okay.
The self-lacing.
What's next?
Lacing Nikes.
Here we go. I love this. Okay, good.
Hi, Austin.
Set A. All 2-digit multiples of 6. Explain whether each of the following statements is true or false. Remember that This means is an element. This means is not an element. Okay? So each answer is going to be true or false. Part A. Is 12 in set A? Is that true?
Yes.
Yes. It is true. Is 6 in set A?
Yes.
False.
No, it's not 2 digits, so it's false. 21 is an element A. Is that true or false?
False.
It's false. It's not a multiple of 6. The number 30 isn't in A. True or false?
True.
False.
False. It is. 81 isn't an element of A. True or false? It's true. It's not an element. It's not a multiple of 6. 78 is. 84 is. 81's a multiple of 3. It's a multiple of 9. Not a multiple of 6.
You're giving me a flashback
Okay?
of what I used to
Okay?
grade.
Here's the thing about logic, too. Again, remember who I am. I am on the assessment team. I am part of I'm one of the cogs in the wheel that make up your exam that you're going to be doing in June, and the exam that everybody's doing in June. But here's what I can tell you. Logic questions require some previous math knowledge. What have we talked about today? We've talked about multiples. We've talked about prime numbers. We've talked about whole numbers. Those are things that you should have learned in grade 9 and 10. If some of those things aren't perfect, don't worry. We've done exams and we've even talked about alphabet, and students have forgotten how many letters are in the alphabet. So just try and jog your memory. When you see something like prime numbers, have a little conversation with yourself and say, okay, do I remember what a prime number is? Okay. And if you do, great. If not, remember we've got math dictionaries in the classroom. Use them. Okay? Use them. They will come in handy. Okay. So, give an equivalent set to 2, 4, 7, 11, 16. Okay? So remember what equivalent means? Equivalent means
Close to.
has the same number of elements. So we need to have a set with 5 elements in it. Wow. It's a perfect. We've got Tanis, Jacob, Josh, Scott, and Trevathan. The $1 million question is, does this have the same number of elements as 2, 4, 7, 11, and 16?
Yes.
Yes. So it is equivalent to 2, 4, 7, 11, 16.
It's the amount of.
Okay? All right.
Wait, how is that equivalent to us? No, wait.
They both have 5 elements.
Oh,
That's what equivalent sets mean.
okay.
Right? Go back to our definitions. Yep. Sets which have the same number of elements are called equivalent sets. Yep, that works. And obviously, those two sets have nothing to do with one another. Okay. We talked about the null or empty set. Okay? Alright. Now what we're going to do is we're going to talk about... Suppose we're looking at the set G equals spades, hearts, diamonds, clubs. When we want to know the number of elements in any set, we use the notation n bracket x, which basically means x is a set, and we want to know how many elements are in the set. So if we define this as the set G, ng is the number of elements in set G. Well, there's 1, 2, 3, 4 elements. So the answer is 4. I talked earlier about math being sets in general is a language thing. All day so far today, we've talked about putting stuff in brace brackets, in using set notation. We don't do that here, and here's why. the question is not asking us for a set. It's asking us how much stuff is in the set. And if we look at how much stuff is in the set, well, we've got spades, hearts, diamonds, and clubs. There's 4 things in the set, so the answer is 4. We do not use brace brackets. We do not, because it's not a set that we're talking about here. Now, here it does say, give an example of a null set. And I gave one earlier, so I'll give it again. The set of students from Brochet taking applied math 4DS right now. That is a null set because there's no elements that go in that set. Okay? Question?
Is the S in 40S, is it lowercase or uppercase?
It's uppercase. Yeah, it's uppercase. It's just the old way of naming courses. They've named courses like that in Manitoba for like 20, 30 years. Okay? So that is the set. That is an example of a null and empty set. Now that's all the examples that were on your page, right?
Yeah.
Right on. Okay, good. So there we go.